Wow. Huh? Wow. Wait, it might get canceled. Are you worried it'll get canceled? All right. Okay, last class, you guys took your calculator test, and then you should have done most of these notes for homework. I think there was one we skipped though with a secant squared. So if you'll just flip to number 10. Okay. Number 10. All right. So if you have not watched the note, you know, that's like bad job. Okay, but it's okay. The way that you do the notes last time is you're gonna take. Oh, good. What happened? Oh, water. Is it just water? Oh no. Here, I have real paper towels.
Stop.
It's okay. Okay.
Yeah, I mean, it's probably. No, it's too red.
All right. Okay, so you should have learned last time. All right. That when you are doing an integral, you're going to take the antiderivative. You're going to plug in the top value, plug in the bottom value, and then you're going to minus them. Okay? So the beginning part of this, you should already kind of know how to do. But we're going to do number 10 just to make sure you remember how. Okay? Yes, Benji? You can sit anywhere. So secant squared, what is the antiderivative? It is tan. Very good. So secant squared is going to go to tan x plus c. Now remember, the plus c is always there. Okay, and then you're going to plug in the two endpoints and then subtract them. So my capital F at pi fourths is going to be the tan of pi fourths plus c. And then for pi 6, I'll have tan pi 6 plus c. Okay, then let's remind ourselves how to find tangent. Do you remember? Sine over cosine. Very good. So if I find for my hand trig people, pi fourths, that's your middle finger. And then remember, sine is the down fingers. So how many down fingers are there? So it's root 2 over 2. Let's put it right here. So this would be sine pi fourth divided by cosine pi fourth. And we got root 2 over 2. Okay, now if I'm on pi fourths, because that's my middle finger, my bottom is root 2 over 2. But what about my tops for cosine? How many fingers? Still root 2 over 2. And if I divide a number by its own self, what am I going to get? 1. Very good. Okay. So my top value comes out to be 1. Okay. For pi 6, find that finger on your hand. Remember, it's 0 pi 6. Fold it down. Sine is how many fingers below? 1/2. Divide by cosine would be how many top fingers? Not 4. 3. So it'd be root 3 over 2. And then remember, when you're dividing fractions, you're going to change, flip. So keep the top one the same, change it to a multiply, and then flip the bottom. So my root 3 over 2 is now a 2 over root 3. And then if you have a 2 top and bottom, what can you do with those? Cancel them out. So it would really just be 1 over root 3. Okay. Now, technically, I forgot to write it. Both of those have a plus C. Okay, but if you watched in the video, what's going to happen to the C's when I minus these? They're going to always cancel out. So if you want to just not put the C, AP test won't kind of wrong. Okay, so the C's are going to cancel out. And my answer is going to be 1 minus 1 over root 3. Okay, which would be perfectly acceptable on the AP test. In pre-cal, you talked about you can't leave square roots on the bottom. Okay, but for the AP test, they really don't care about that. You'll get full credit either way. Okay, are we all good on that? All right, if you will, please turn ahead to number the mixed methods on the back of that page. Okay, we already did these top two like last week at some point. So we're gonna now just do the bottom two that go with it. So let's say that we're doing this guy right here. Remember that if you have a constant that is multiplied with your integral, you can just work the integral out, times it later. But if it's a minus, look at how we did these last time. Okay, you have to separate them each into their own integral. So we're going to do that same thing here. So if I have the integral 2 to 6 on g of x minus 3, I'm going to do the integral from 2 to 6 on g of x. Then I'm going to do the integral from 2 to 6 on 3. And then once I find those two values, I'm going to subtract the answers. Now, we can't use this graph, okay, but because that's a graph of f, but they give you some information about g right here. So let's look at what they've given us. We want the integral from 2 to 6. They tell us 2 to 5 is 4, and 6 to 5 is -3. So that's enough information for us to know what this integral is, but remember we do that little number line thing. So I'm going to draw my number line here. What is the longest of those g integrals? Is it 2 to 6, 2 to 5, or 5 to 6? 2 to 6. My stopping point is going to be 5. And then from 2 to 5, how much area is there? Okay, it tells us there's 4. From 5 to 6, what will I mark the area? +3, because how did they give it to me here? Backwards. So don't forget to flip that sign. So then if it's 4, then 3, what's the total area? Okay, this would be a 7 minus. Okay, then when I get to this integral, okay, I'm going to do, now we know how to do the fundamental theorem of calculus. So can you tell me, it's just a 3 in there, what's the antiderivative of 3? 3x. And then what would I plug in? 6 and 2, then subtract that. So capital F of 6 would be 3 times 6 is how many? 18. Technically, there is a plus C there. Okay, if you want to try to squeeze that in, that's fine. It'd be 18 plus C. What is my bottom value that I'd be plugging in? 2. Capital F of 2 would be 3 times 2, which is 6 plus C. But then remember, if it's this minus that, those C's are going to always cross out. How much area will be left for this guy? 18 minus 6 would give me 12. Now remember, that's not my final answer. That's just the answer for this integral. And then how was I combining the integrals? By addition or subtraction. So 7 minus 12 would give me -5. Okay. But the reason these are different methods is that you're doing fundamental theorem on one, number line on the other. Or if you look at the top here, we were doing the graph on one and then a separate graph on the other. Okay. So what I was thinking is maybe when we transition to your homework, we can do one of these off the homework together. Okay. If we need to. All right. So separate your second one. 2 to 6 on g of x minus x. We would do 2 to 6 on g. And then 2 to 6 on x. But we already know the answer for the first part of that. 2 to 6 on g, how much area was it? 7. And then for this one, I'm going to have to do fundamental theorem on it. What is the antiderivative of x? 1/2 x squared. Okay, I'm going to leave off the plus c, but we kind of know it's there. Then we're going to plug in 6 and 2 minus the answers. So capital F of 6 would be 1/2 of 6 squared. What is 6 squared?
36.
Cut it in half. Oh,
18.
18? Yeah, 18. Okay, and then we're plugging in 2. So that'd be 1/2 of 2 squared. 2 squared is 4. Cut it in half is back to 2. And then remember, it's this minus that. So 18 take away 2. My second integral's value is 16. And then I'm taking those two integrals, I'm subtracting them. So 7 minus 16 would give me negative 9. Make sense? Okay. There's only one more page left on these notes, and it's a formula for average value. So if you'll turn the page one more time. What? No. It is pretty short. Okay, the average value formula is 1 over b minus a, integral a to b. Okay. So 1 over b minus a, integral a to b. So let's do that on number 13. So take a look at your equation. It says to find the average value, okay, of this equation right here. So let's set up our formula first, because average value is a formula. It's 1 over b minus a. Now my a is the first part of my interval. The second is my b. So what would the beginning fraction be for my average value formula? It'd be 1 over 2 minus -1, which you're correct, it'll turn into a plus. Okay, then integral -1 to 2 of my f of x dx, which is 2x squared plus 1. Okay. Then from here, you can now work this integral out. Okay, what is the antiderivative of 2x squared plus 1?
2/3 x cubed plus.
Okay, 2/3 x cubed. Because remember, I have to up my power by 1, so squared goes to cubed, then divide. And then my 1 is going to go to a 1x. Okay, nobody cares about the plus c, so we're not going to put it. And then I'm going to plug in 2. Then I'll plug in -1. Okay, let's do 2 first. What is 2 cubed? Okay, 8, it'd be 2 times 2 is 4, times 1 more 2 is 8. So then I have 2/3 times 8 plus, and then this would be another 1 times 2. And then 2/3 times 8 would be 16/3. Are we okay with that? Okay, technically the 8 is part of the top, so you just times them straight across the top, straight across the bottom. Okay, and then 1 times 2 is a 2. Okay, just leave it like that. Now let's do the bottom. I'm plugging in a -1. What's -1 cubed? Still -1. And then plus 1 times -1 would make that a -1. Remember, times straight across the top, so this is now a -2/3 -1. Okay, from here, remember, it's this minus that. What am I going to get? Let's do it in the fractions together first. If I do 16/3 minus negative 2/3. 18/3. Because remember, minus a negative really means you're plussing. So 16/3 minus negative 2/3 is 18/3. How much is that? 6. And then what is 2 minus negative 1? It'd be 3. And then what's 6 plus 3? That'd be 9. And then in the front, I had this little fraction here. We said 2 minus negative 1 is really 2 plus 1, which means that I want a third of that integral. And what is a third of 9? 3. Okay. So let's talk about what you just found. So we did the antiderivative. We took the third of it. We got 3. On your graph, this is a graph of that equation. I want you to highlight or kind of scribble on the sections of the graph between this interval. So negative 1 would be, we'll say here. And then I want you to shade all the way till 2, which we'll say is about here. So it'd be all this part of the graph. If you took all of the y values from here to here and you average them, the average is 3. So if you draw in 3, we'll say this is 3 about right here. That means that all of these and all of these average out to where 3 is like the perfect middle point on the graph. Okay. Does that make sense? So it's the average height that you have. This half of the graph is below it, and then this half of the graph is above it. So it's like the middle point. Okay. So go ahead for number 14. Set up your integral on your paper, and then I want you to do it in the calculator. Okay, because we want a number. Yes. Oh, we haven't done it yet. We'll get it.
Well, with X. That's with X.
So you're going from 0 to 2. So your average value should start off with 1 over 2 minus 0. And then integral 0 to 2. Okay, and then you're just going to actually do it in the calculator. Yes. Oh, you want yeah. So in my calculator, here's what I'm typing in. Alpha x for my fraction, I want 1 over 2 minus 0. Math 9, 0 to 2. And then if you haven't typed your equation into your y1, just put the equation in there. So I'm going to put in e to the x. And then it'll give you the average height or y value of this function between 0 and 2. So it comes out to 3.195. Okay, but this time we did it on the calculator. All right, so the average value, I'm going to put it right here, and then we're going to show it on your graph. On your e to the x graph, I want you to only kind of shade or highlight from 0 to 2. So 0 would be here. 2 would be here. And then if I kind of shade that part of the graph, what it's telling me is that half of the graph is below 3.2, which would be about right here. So we'll say this is our y equals 3.195. Okay, half of the graph is below, half of the graph is above. That's like your average y value for your equation or your graph. Okay? Now, you'll notice that both of these questions are not finished. It says the average value is 3.195 and it occurs at, well, let's just kind of guess from the graph. If 3.1 is about here, what is about the x that happens at? 1.5, maybe somewhere around 1, but a little bit bigger. So let's review how to find that. So in your calculator, go into y equals, and I want you to type in e to the x as your y1, and then 3.195 as your y2. Okay, and then you should know how to find where those graphs cross each other from your test last week. So I'm going to do second trace, and then option number 5. You'll notice these graphs only cross once, so you don't have to like get close to a certain one. You can just push enter. So first curve, enter, second curve, enter, guess, enter, and then it'll give you your answer. Okay. So it's 1.162. Which is right about where we estimated it to be in the first place. Okay, we're going to do the same thing for the other question. Remember, on that one, our average was 3. So type in your equation as your y1. So it's 2x squared plus 1. And then our y value average was 3. And then you're just going to find where those cross. So my graph is zoomed kind of weird, but you should see how many intersections this time. 2. So the problem with that is that you need the intersection that you pick to be on the interval that you're talking about. So if I'm only looking from -1 to 2, then I want this one. So go ahead and push enter on first curve, enter on second curve, and then you're going to find the second intersection. So second trace 5, enter, enter, and then on your guess, get closer to the one that you want. Okay, and it comes out to +1. Now, looking on our graph, does that kind of make sense where we drew it? Okay, that looks about right. So it'd be at x equals 1. Okay, now there is a theorem that promises that this is always going to happen. So if you'll just look at what's called the average value theorem, okay, it's written right here. If your function is continuous, then there has to be, or there must exist a c such that f of c is going to equal this formula. So it's 1 over b minus a integral a to b f of x dx. Okay, and if you think about, you remember the intermediate value theorem? Okay, that any number between the endpoints had to happen. Okay, well, an average should be between the endpoints. So really, this is kind of IVT again, just for like a special number. Okay, that whatever the average value is, there had to be a spot where that was the actual y value. Good? Okay. So, because we had to finish these notes, we're gonna kind of rush through what y'all are learning today, but it's really not very hard. So we're gonna learn how to do a Riemann sum. Okay, and we're gonna kind of skip the word problem part of it and just get into how to do it. Here you go. But it's okay. You'll have time to work like 30 minutes. Oh, you're done? Perfect. Thank you. Yeah, you're in. Are you a junior or senior? So then you still go to second. but not till 1. So you go to your holding room and then you come to, I don't remember the order. Did you email me? Will you email me just because it doesn't, I have the notifications turned off. So just email me. Yes. Yes.
Hypothetically, I get sick from 8:50, but I only get 1 absence.
Honestly, I have no idea how they're gonna do it.
On Thursday,
Tomorrow.
no, I didn't, like on Thursday, the same thing happened, right? So we have-
Yeah, it's Wednesday and Thursday.
Yeah, I think depending on if the game gets canceled, I'm gonna be blocked, so I won't be here.
Okay, no worries.
If it is canceled.
Okay, no worries. All right. So here's what a Riemann sum is. Okay, do your best to give me a very rough, we're skipping the little word problems on the front. Okay, do your best to give me sort of a graph of the data in this table. So we're going to make this very, very generic. So 0, 88, boom, there it is. Okay, then at 1, I want to be at 45. We'll say that's about half. Okay, then 1, 2, 3, I want to be at 22. 4, 5, 6, I want to be at 16. 7, I want to be at 8. 8, 9, I want to be at 5, and then 10, I want to be at 2. Okay, very, very rough sketch. Okay. Let's say that you want to know the area, but you don't have the equation. Because remember, if you have the equation, you can do exactly what we learned last time. Take the antiderivative, plug in the endpoints, subtract, you're done. Okay, but let's say instead of having the equation, you just have a few data points. Okay, in this case, you would do what's called a Riemann sum. Here's how it works. You're going to estimate the area by splitting your graph at each of the points that you have. So split it up where those points are. And then you're going to either pick the left or the right side, and you're going to create a rectangle, which you know how to find the area for that shape. So let's say that we're going to do a left Riemann sum. You're going to use the left y value, and you're going to cut across and make a rectangle. Okay, then you're going to use the next y value. You're going to cut across and make another rectangle. Okay, then this y value is going to cut across and be the height of the rectangle for that section. Okay, all the way through, you run out of points. Now, the very last point, okay, the very last point, because it's only a right side, you don't actually make a rectangle with that one, okay? And now, rectangles, we know how to find the area of. How do you find the area of a rectangle? Based on type, very good. So let's do this first rectangle. How wide is the base? 1, so put down a 1. And then how tall is that rectangle if I use this point? What was that y value? 0, 88. So it'd be 1 times 88. Plus. Okay, I'm going to put a little check here to show I did the first rectangle. From here to here, how long's the base? 2. And then I want to know how tall that rectangle is. I use the second y value. What y value was that from the chart? 45. And then I'm going to put a little check that I did it. Okay, third one. How wide is the base? 3. And then I'm going to pick the third y value because that made up the height of that triangle, which is what? 22. And little check. Next one. How wide is the next rectangle? Only 1. And my left side y value is 16. Okay, my next y value, or my next base, how long is it? 2. And my y value is 8. Last one, it's only 1 unit wide, but how tall is my left side? 5. And then remember, did 2 ever get to make a rectangle? No, so that's why it didn't make it into my area formula. Okay, then for your homework, you would add those up in the calculator, but we're not doing that right now. Okay, let's now switch to a right Riemann sum. So imagine the same graph, but this time you're going to let the right side of every interval pick the height of the rectangle. So here's what I mean. From here to here, this first little subinterval, I'm going to let the right side be the height. And then from here to here, the right value gets to pick the height. And then the right value gets to cut across. Right side, right side, right side. So here's what's gonna switch when you do a right Riemann sum. Which y value never got to be the height of a triangle? So this time 2 got to be in charge of this one, right? Now it's 88. See how 88 never got to be the height of a pink rectangle? So if it's a right Riemann sum, you're not going to include the first y value. Versus for a left Riemann sum, you never use the last y value. So let's set it up on your paper. From 0 to 1, what is the width? 1, and I want you to mark it on your table here because usually you would not like do a picture like this. So from 0 to 1, it's 1. My right y value is 45. Plus, from 1 to 3, what's my width? 2, and my right side value is 22. From 3 to 6, what's my width? 3, but my right side y value is 16. That's correct. Next one, from 6 to 7, what's my width? 1, and who's the right side y value? 8. From 7 to 9, what's my width? 2, and then I would use the 5. Okay, and then last rectangle, from 9 to 10, my width is 1, but I would use the right side y value, which is 2. So for my left side, I never use the first point. Never use, I think I said that wrong. For a left side, you never use the last y value. And for a right side, you're going to never use the first y value. Okay. Now, let's say we're trying to find the actual area. So I want you to just kind of loosely connect your dots. Okay, maybe the graph looks something like this. The green arrow or the green areas were the left side. Are they probably too big or too small? They're too big. You can tell the greens are above where the graph is. That's an overestimate. Versus for my pinks, when I drew those in, how did the pink areas compare to the real area under the curve? They're an under. Okay. Now, the reason that the left and rights are the way that they are is based on whether your function is going up or downhill. So because this is a decreasing function, let's put a because on this. So we're saying it's an underestimate because my function is decreasing and we use the right side. A right Riemann sum. Okay, versus if it was an increasing function, the right side would come out as an over. So you really have to think about, first of all, which way is the graph going? And then second of all, which side did I use? Okay. So if you will, please turn the page to number 5. Okay, we're gonna try one more left and one more right. So let's do number 5, part B. It says use a left Riemann sum with the subintervals indicated in the table. So my first interval is from 0 to 3. How wide is that? Sorry, 0 to 30. That would be a width of 30. And then which of those y values would be on the left? 20. Okay, next one. Now I'm going from 30 to 40. What's my width? 10. And which is my left y value between the 32 and the 41? 32. Okay, next one. I'm going from 40 to 50. How wide is it? 10. And what is my left side y value? 41. Notice you're just going in order. Okay, from 50 to 70, what's my width? And then what's my left side y value? 55. Last one, from 70 to 90, what's my width? 20, and my left side y value is 65. Who never got used? 72, but for a left Riemann sum, you skip the last. Okay, now it does ask if it's an over or an under. So just kind of draw in your picture to see which one it is. Slice your graph where the dots are. And then remember that if you did a left Riemann sum, you're going to start on the left and cut your rectangles across that way. So what I mean is I'm going to start on the left and cut across. Are my rectangles too big or too small for the actual area under the curve? These are too small, so this would be below the actual value. Okay. You have one more left like that below. We're going to skip the picture and we're going to do just the right Riemann sum. So we've already done a couple lefts. Let's do the right one. Okay, first question. What is the width between the first 2 points x values? 2. And now we're doing a right Riemann sum. Which y value will I use for a right? 17. And notice the 22 is not going to get used, right? Okay, my next width is from 2 to 4. What's the width? 2. And what's the right side y value?
13.
This time it's 13.
13.
Okay, my next y value, or sorry, distance is from 4 to 6. That's another width of 2. My right side y value is 10. Okay, 6 to 8 is another 2, but this time I'm multiplying it with a what? 7. Then 2 times 5. Then 2 times 2. Okay, but once you've skipped the first one, you know you're going to use all the other ones. And I observed there that all my distances were 2. Okay. Then draw me a picture of a graph going. This one starts at 22 and stops at 2, so make it downhill. Cut your graph. Let's cut it in half. And then let's just draw our rectangles in. That's enough. If I use the right side, where will my area be? Too big or too small? Too small. If I pick the right side and I cut it across, I see that I'm going to miss a lot of area. So this one would be an underestimate. Okay. All right. There is one more type that you need to know how to use or how to do. So turn back to the question we started with for our midpoint. Okay, and then I'm just going to copy my same graph that we had before. All right, so our left and our right, one of them is going to be too big, one of them is going to be too small. So the last option for a Riemann sum is that you could do what's called a midpoint Riemann sum. Here's how a midpoint works. When you cut your graph, instead of slicing it at every y value, you're going to skip one in between. So here's what I mean by that. You're going to cut here, skip, cut here. Then you're going to skip, cut here, and then skip, cut here. So when you split your graph into your rectangles, you're going to skip one in the middle, and that y value is going to form the height of the rectangle. So instead of picking the left side or the right side, you're going to pick the middle one that you skipped. So I would draw in my height here. And then here. And then. Now, the reason the midpoint is considered the best out of the Riemann sums is that if you draw in your actual area, do you see how it's not always over or always under, that you have a little bit of a mix? And so what happens is that all of this area that's too big and all of this area that's too small, they kind of help like cancel each other out. So they make this the most accurate of the three types, because you'll have a little area that's too much, but then a little area that's not enough, and it kind of just works itself out. Okay, so let's learn how to do it on the chart. So you're going to go from 0 to 3 because you're going to skip one. So what is that width? 3, and then the middle y value is 45. So put 3 times 45 plus. Okay, then I'm going to go back to my graph. I already went 0 to 3. Now I'm going to go from 3 to where? 7. And what y value am I going to use in the middle? 16. So the width from 3 to 7 is how many units? 4, and the y value I'm going to use is 16. Okay, last one. I'm going to go from 7 till when? 7 to 10, and my middle y value is 5. The width from 7 to 10 is 3 times 5. Okay, and then it says, is it over or under? You would put, you cannot know, but we know it's more specific than a left or a right, or we'll say more accurate. Okay. So you can't know for sure if it's too big or too small, but you know it's going to be closer than either of the other ones. Okay. And so now we'll do a midpoint on number 6, the one we just finished. Okay, so what will my first section be if I have to skip one? I'm not going to go 0 to 2. I'm going to go 0 to what? 0 to 4. How wide is that? 4. And then what's my middle y value? 17. Plus from 4 to 8, how wide is it? And my middle y value would be 10. Very good. Okay, then from 8 to 12, that's another width of 4, and your center y value is 5. You get it? Okay. Pull out your Chromebooks and get into the first question.
They're not doing that. They're only really here. Very, I'm not. It's not here, it's very.
Can I go to 5? Yes.
I'm not even assuming lesson.
Very, it's a very funny real.
I forgot.
Bad friend.
No, it's someone like the really good page by someone I follow. So I see
You'd already
stuff all
seen
the
it?
time.
Wait, so that's unironically like a thing to do.
Do you try to reply to every reel you get?
I get it.
I was gonna say, unless it's really funny, like if it's like in my like.
I have so many people that
Wow, it's like you're fake too.
It's not-
It's not like I said, like a trail of like, wow, it was just one.
Oh, okay, so
Yeah, no, he.
we usually like in my like sisters chat, we'll send like 2 messages like every single. I'll try to respond to like one in each batch, you know?
That's how we do it in my family.
I usually try and get all.
All right. So you should hopefully have this first question up. If you don't, it's okay. I'm gonna give you a formula to find out the width, but if you just logically think through it, you really shouldn't need a formula. Okay, how wide are we shading from 0 to 2? How many units? 2. And I want to divide it. If you read on the question, it says we want to divide it into how many pieces? Okay, it says 5 equal pieces. So if I take 2 in your calculator, type in a 2, and then divide it into 5 equal pieces. What is 2 divided by 5? 0.4. Okay, then hit go. And I think I'm going to have to actually log out. But you should have your graph should have split up into boxes. Did it do that? Okay, hold on. Mine's not working. Okay, did it do that? Okay, then do we want a left or a right Riemann sum? Right, then you're gonna adjust the middle dot so that the right side dot is touching the graph. Okay, you're gonna adjust the middle dot so that the right side dot is perfectly on the graph. Okay. Good on that? Okay, then it asks you, is it an over or an under in this drop down? Look at your green boxes compared to where the actual area would stop. Are they too big or too small? Okay, so overestimate or over approximation. And then it says because you're gonna only answer increasing or decreasing. Concavity has nothing to do with whether it's over or under. So which way is this graph going? It is increasing, so you would pick increasing. Okay, and then submit.
Got it wrong.
No. Did you really? Make sure all your right sides are touching.
Oh, this wasn't.
No, that was fine. No, that's
I think it was off. It was like right here.
Oh, yeah, they do have to be flat. And then you did over because it's increasing. You get it? Okay. So for the first part, y'all, the formula that I said I was gonna give you and I forgot is if you want to know how wide, you're gonna do B minus A and then divide it by how many rectangles. So what I mean by that is you're gonna do B minus A and then divide into the number of pieces that you want. So in this case, 2 minus 0 is 2, and then I divided it into 5 pieces. Okay, so subtract to see how wide it is, and then divide it into the number of pieces that you want. Correct. So what's 2 minus 0? And now we're gonna divide it into how many pieces? 4. What's 2 divided by 4? 0.5. Very good. Then you'll hit go. And now you're gonna adjust. You want a left, right, or middle?
Oh.
Midpoint. So then now when you adjust, your middle dot needs to be the one that stays on the ground. There you go. Does that make sense? And if it was a left, you would make sure the left side is aligned. It does have to be. Yeah. Oh, that was
Wait, what did I do?
Uh,
Got it right. Not applying.
Did you, here's crooked? Yeah. Yours looks good, yours
Yeah,
looks.
but I got it right first, Barrett. Who's ready to go on, Barrett? It's me.
Pretty sure Ross owns
Who tell you if you put the wrong width?
I don't think it will. But if you see that